So good morning, everyone. My name is Laura Fay. I'm the PI on this project, which was the development of a guide for converting severely distressed low-volume paved roads to engineered unpaved roads. And this is the webinar of the guide that's been developed by myself and Dr. David Jones at UC Davis. I'm now going to hand this over to David Jones to start the webinar.
Can you hear me?
Yes, we can. Go for it.
Just worried about muting buttons and everything. Okay, good morning, ladies and gentlemen. Thanks for joining us this morning to talk about this pretty controversial topic. But as when we were at the Low Volume Roads Conference in Kalispell in September a little while back, a couple of the old gurus of unpaved roads in the United States basically told the audience that, like it or not, unpaving is here to stay for at least the short to medium term. So even if we don't agree with it, we don't like it, unpaving is going to happen. But it's obviously important to do it in a formalized process. So yeah, we're going to be talking for around about 60 minutes. I'll be sharing the presentation with Laura. We'll just basically take you through the guide, and then we've got about 30 minutes for questions after that. All right, so to get going, just a quick outline for the webinar. It's basically providing an overview of the guide. And since we only have an hour, we're going to be telling you primarily what is in the guide. It's not a workshop on how to unpave a road, because we can't squeeze that into an hour. It is a scaled-down version of a 3-hour workshop that we held at the 12th TRB International Conference on Low Volume Roads in Kalispell around about a month ago. And that was very well received. Seems that we do have some relevant information in the guide. So the presentation is basically based on the guide chapters, and we'll cover a quick introduction to unpaving, discuss the chapter on identifying candidate roads. We'll then move into the road investigation, everything that we believe needs to be done in order to ensure that we get a good product at the end of the day. Talk about the road design, because we basically have to create an engineered unpaved road. So some work on the thickness design, the materials. Can we use the materials in place? Do we need to add supplemental materials to that? Then a couple of notes on road conversion, which is essentially just actually taking that distressed paved road and turning it into a good quality unpaved road. I'll cover all of that. And then Laura will take over and talk a little bit about the life cycle costs and dealing with the public, which is a very important part of the process. And then Laura will facilitate the questions at the end of that. Okay, so the focus of the guide is really making sure that we upgrade the road that's in its current condition and turn it into a better engineered unpaved. Under no circumstances do we want to take a bad situation and make it worse. So if we're going to embark on this process, then we need to make sure that we do it well and that the unpaved road is going to perform much better than the distressed paved road is right now. Okay, so moving on to the introduction. So as we're well aware, the US road network is around about 4 million miles, and about 1.4 million miles of that is unpaved. And if everything we know about the unpaving process and the interest and the conversions that are actually happening right now, then this unpaved road part of the network is actually increasing. So paved or unpaved, a big proportion of that road network is rural and low volume, and has limited engineering. A lot of the roads have evolved over time, so they were unpaved roads. They were paved. A lot of them probably shouldn't have been paved, but because there were funds available, and with the idea of road agencies to continually improve what they have, those roads were paved and perhaps not as well as they could have been. A lot of that work was done in the 1970s and 1980s, but with changing economic times, less funding available for maintenance, a lot of those roads have not been sufficiently maintained. They've come to the end of their useful lives. They might have been subjected to a whole lot more traffic, but bottom line is a lot of that road network is now requiring major rehabilitation or reconstruction, and we're living in an era when funds to do this in a relatively short period of time are just not available. So converting some of these roads back to an engineered unpaved road standard is one option. It's not the only option. There are obviously other things that you can do: recycle them, repave them, do a proper rehabilitation job and get it back to a paved surface. There are lots of options out there. So converting them is just one option. It needs to be done carefully to make sure that, as I said, we're not making a bad situation worse. It's usually also not the solution that the public expects or wants. So a lot of these projects are driven by public complaints and having to deal with them. But the public in general, as they complain, are generally hoping for a new paved road. The last thing they're expecting is an unpaved road. What we are finding from interviewing folks that are doing this is that the roads are often or can be safer in an unpaved standard than they can be in a paved standard. If you look at the photographs on the right-hand side of the screen there, one road that's basically blowing up from freeze thaw and just water ingress into the pavement. Vehicles are needing to swerve to avoid those potholes, potential for vehicle damage, etc. All of those issues are a problem, whereas an unpaved road that can be relatively easily maintained with a grader can often provide a safer and better ride than that distressed paved road. And of course, if we do it properly, we do a good job of it, we make sure our materials are good, we make sure we maintain it, we use a chemical treatment where appropriate. If funds permit later on, then we have a good quality base that we can build on and bring that back up to a paved standard. The project really kicked off from a National Cooperative Highway Research Program synthesis project that Laura and Ken Scorseth and I did. That was completed in 2015. So that was just a look at what was available out there and what people were doing. There were a series of recommendations that came out of that study. One of them was the overwhelming need identified by the people that we had interviewed was some kind of formalized guide that said, this is how you do it. This is what you need to look for. This is how you need guidance for how to deal with the public, etc., etc. And a research needs statement was put together based on those recommendations, and the Minnesota Local Road Research Board decided to fund that. In terms of putting it together, it's based on the experience that the authors had developed during conversions in a number of states. We've basically just taken that experience and practice and put it into a step-by-step guide that'll hopefully help people make the right decisions in going forward. The guide includes chapters, as I said, and basically how this presentation will go is identifying candidate roads. What are the key things that would justify an unpaving project? Doing the road investigation, designing the road, some guidance for actually doing the conversion. It is essentially building an unpaved road, but obviously we have to factor in that existing surface that's on the road. Some information on cost analyses to determine whether it is going to be more cost efficient to do the conversion or whether a conventional improvement would be more cost effective. some assistance with public involvement, and then there are also a series of appendices in the document that provide additional information on the information that is provided in the chapters. And as I mentioned, the aim is to provide a better level of service than the current distressed paved road, and all of that done at a reasonable cost that agencies would hopefully be able to afford. Okay, so when is a road a candidate for unpaved road? There are a number of factors that need to be considered, primarily, again, based on the experience that we got when we were doing the synthesis study, was economics. So the cost of continuing to maintain the paved road at a reasonable standard gets very expensive. If we have to do patching, we have to do crack sealing, we have to do dig outs, etc. All of that in terms of that photograph that's on the top right-hand side of your screen tends to be very labor intensive. So it's labor intensive patching. And it seems to be a never-ending story to try and keep that in some kind of rideable repair. So that becomes very, very expensive to do that. If it's an unpaved road, it's simply just a grader maintenance and perhaps some form of chemical treatment that can keep the road in that condition, as we see in the photograph on the bottom of the slide. But obviously the road agency is going to need to factor in those costs for the graders. They might have to change some of their fleet to be able to undertake this maintenance. More graders, less pavers kind of situation. They're going to have to factor in chemical treatments if they are doing dust control, fines preservation, trying to keep all-weather passability. So those costs are going to have to be factored in. It's not a case of just, well, we unpaved it, therefore the costs are going to reduce significantly and the maintenance is basically going to take care of itself. That doesn't happen. There are still going to be costs involved, and they're going to have to be taken into consideration. Safety is obviously an issue, so bad paved roads can be dangerous, and there is also the perception that unpaved roads are not as safe as paved roads. But again, if they're well maintained and they have a chemical treatment on them to control any dust and fines lost, they are often safer than the distressed paved road might be. So that is also a very important factor that needs to be taken into consideration. Traffic is also an issue. It's generally accepted that ideal candidates for conversion are typically roads that carry less than 100 to 150 vehicles per day. Again, it's going to depend on what proportion of that is trucks. There are certainly a lot of cases where roads with more than 150 vehicles a day have been converted, but the agency needs to keep in mind that the maintenance costs will increase. You will need to do greater maintenance a little bit more frequently on that, and you might have to rejuvenate your chemical treatments a little bit more frequently. But certainly is feasible to do that. We've seen projects and we have records of projects that have been done up to 400 vehicles a day. We're not advising that or advocating that. We're certainly looking at trying to keep the candidate projects at around about 100 to 150 vehicles per day. And especially those kind of roads that if you did an economic justification for paving now, that those roads generally wouldn't be considered as economically feasible to upgrade. So generally those lower traffic volume roads. Another factor to be considered is what is causing the distress in that paved road. A lot of the roads we're seeing that are being converted are generally those roads that are just well beyond their use by date. The asphalt or the chip seal surfacing has aged considerably. And we're essentially getting into what we would call a passive conversion. The photograph again on the top right-hand side of your screen, you can see a little bit of paving and a little bit of gravel that's already started to washboard there. These are again ideal candidates for unpaving. If we're having structural issues where we have severe rutting in the road, we have severe fatigue cracking because we're having a lot of deflection in the roads. Those are going to require a little bit more care because invariably we will have to bring in some additional gravel to improve the structural capacity in order to carry the traffic that it is carrying. So again, not excluded, but may require a little bit more effort and a little bit more cost to bring those up to an all-weather standard. Environmental concerns are also out there, so dust, erosion, water pollution, frequent gravel replacement after we've converted that road to an unpaved standard. Those are all concerns that are going to have to be considered. They can obviously be mitigated by good design and the implementation of appropriate chemical treatment programs. Another factor that needs to be considered are agency resources. If you're going to embark on an unpaving program, you're going to have some good public relations capability. You're going to have to deal with the public a little bit more often. It is a controversial subject, and there are the good ways and bad ways of dealing with the public. The public certainly doesn't want to be surprised by driving on a paved road one day and an unpaved road the next day without any kind of communication according to them. The agency might also need to acquire additional skill sets. So if the road network is primarily paved and they switch to an unpaved road, they're going to have to get some skills in terms of designing and maintaining those unpaved roads. And as I mentioned before, might have to change some of their equipment as well. So on your screen now, I don't expect you to be able to read all of this. This is a flowchart that is included in the guide that basically takes the reader through the decision process. So it's just a simple case of questions with a yes/no answer, and you basically follow the flowchart all the way through, and it will hopefully take you out at the bottom and tell you, yes, this is a project for a candidate project for unpaving or not. So again, starting up at the top, it basically goes through history. So if you've had a bad history of unpaving and you don't believe that you can address a lot of those problems, then you might want to reconsider doing another one. Next level is what's happening on the side of the roads. Is there any kind of critical activity, sensitive farming or something like that that would not be able to accommodate dust or any other kind of activity, maybe some additional roughness. Next level is costs, to do some kind of a basic cost analysis to see if maintaining the road in an unpaved standard would be cheaper than trying to maintain it in its current paved road standard. Next level is safety issues, then traffic, and then the causes of distress. Is it structural or is it just basically age-related? Any specific environmental concerns that can't be dealt with, and basically a process for dealing with the public involvement. So just a series of yes/no answers, and if you can deal with all of the concerns that are raised, then it's worthwhile proceeding with an investigation. Alternatively, you might want to look at another option. That kind of wraps up that part of the process. So if you've done that part of the study and you believe that that unpaving is still a good option for you, then the next phase is to move into the road investigation itself. This is really important to do, and we've seen people, and I've seen people in the projects that I've been involved, basically burn their fingers pretty badly when they don't do the investigation, because invariably if you miss something and you do that conversion and the road is worse than it was before, and you end up having to do a lot of maintenance, then it's going to come back and bite you if you do that. So we encourage to do a good quality investigation, and so that'll help you to come up with a reasonable design and a good quality conversion. The purpose of the investigation is to essentially to gather information on what is out there and why it looks like it does, because you're going to have to address those issues and make sure that it doesn't get any worse. You're going to use the information that you collect to determine whether the road is a candidate, if there are sufficient appropriate materials out there, or if you're going to need some additional supplemental materials on the road, and any problems that need to be corrected first, like, for instance, drainage, maybe some safety issues, some geometric issues, some additional signage that you might need to put in place to keep the road at an acceptable, safe level. The costs of doing the investigation are negligible. It's just really a drop in the ocean in terms of the costs of doing the conversion itself. It doesn't take long, and it's basically you should not be using cost as a reason for not doing the investigation. And as we like to say, it's not rocket science, it's just rocks and a bit of science. And essentially, it's really common sense. So if you take a look at the photograph on the top right of the screen here, it's basically taking a look at a distress. What's causing this distress? Is it related to the drainage? Is it related to the materials? Why is this section of the road worse than the rest of the road up the top there? So it's just a case of walking, taking a look, and it's usually pretty easy to understand exactly what the problems are. 4 key steps, essentially a desktop study. So it's just basically to gather some basic information before you go out and start digging holes in the road, identifying some fatal flaws on that desktop study that's already going to exclude the road from being a candidate. Then the actual physical road investigation itself, getting out there, doing the walkthrough, checking your areas, checking what materials you've got. Taking some material samples out of the road to understand what you've got and analyzing those test results to see if what you've got out there is sufficient or whether you're going to need some more on the top of it. And then just some basic documentation that's going to guide you into the next phase of the study. So that desktop study, collecting relevant information, identifying any fatal flaws before you've put any major effort or expense into it. We suggest using a checklist to make sure that you've covered all of the areas. We do have an example checklist in the guide that you can basically check off to make sure that you've covered all the bases. Just some of the things you want to be looking at is the history of the road. When was it paved? How was it paved? Was there any justification for it being paved? What kind of traffic is using the road? Is the traffic increasing? Is it decreasing? Is it seasonal traffic? Do you have a lot of traffic in a couple of months of the year on roads that serve agricultural situations? Is there tourist peaks? All of those sorts of issues. Weather issues, what's happening with the weather? Are there areas where you have storm damage, impassable conditions that you're going to need to deal with? Are those situations getting worse? Are you seeing more intense storms that you have to deal with? Safety considerations. Have there been accidents on the roads? Are there any particular areas where you've had public complaints that need to be dealt with? And any other factors like shallow utilities on the road, perhaps some future developments that are going to be coming that are going to increase the amount of traffic. Is there going to be some energy developments in the areas, trucks bringing in windmills or something like that that you're aware of that might lead to changes down the line that might affect your decision. So that's all pretty important to do. You can save yourself some time before you move out. The next thing is getting out there and doing the actual investigation themselves. We suggest walk the road, don't drive the road. You can see a whole lot more if you're walking it. Document your observations. Again, checklists, photographs, all of those good things are really useful to helping you to make a decision and reminding yourself where you might have to put in a little bit of extra effort. There is an example checklist and a form provided in the guide for you to follow. Obviously, you can adapt that to suit your own particular needs. Obviously, you're going to need to identify the reasons and the causes of the distress. Again, is it age-related or is there some other issue that's causing those distresses? And are those distresses going to be a problem later on when you do that conversion? During that walkthrough, you're also going to want to identify representative areas to check thicknesses of the materials and to identify areas where you can sample materials for later testing. Obviously, photographs are really useful along the way. You want to be doing some dynamic cone penetrometer tests. If you're not familiar with the dynamic cone penetrometer, there is information provided in the guide, but this is a very quick and easy test to help you identify how thick your layers are, strong your subgrade materials are. Sorry, folks, there is somebody who's speaking in the background there. If you could just mute your microphones so that you can continue here, please.
It's not cold, is it? It isn't enough. It doesn't take a lot. Well, I got it two of them, 2 or 3.
We've got somebody talking in the background. Please, could you mute your microphone? I'll keep trying. Okay, then you can also use the dynamic cone penetrometer to determine those layer thicknesses, but we are going to have to dig a couple of holes in the road where we take our samples from just to validate what we have picked up from the dynamic cone penetrometer. We've got to keep in mind that there is going to be variability along the road, so we need to make sure we capture that variability and factor it into our designs. Then we want to sample representative materials from the road. So we want to take, depending on how much variability there is, take a sample from each of those locations. We're going to need to test the materials. Okay, very important step. Again, a lot of people don't like doing it because they think it's expensive, but just doing some very simple tests on those materials can tell us a whole lot of how that road is going to perform in the future. Do some basic interpretation of the results to get a basic prediction of how those materials are going to perform and whether we need those supplemental materials. So again, walking the road, as I said, this is covered in detail in the guide. I'm not going to go into detail here, but just looking for general problems, the causes of the distress, variability along the length of the road, what materials do we have on the surface, underneath the surface, and in those subgrades. Is there anything out there that's going to cause us problems in the wet season or in the dry season? We've got to look at drainage. Is the water moving off of the road? Is the water moving away from the road once it gets off the road, or is it ponding on the surface? Are any of these problems that we're seeing on the road related to drainage? And if they are, what do we need to do about it to correct them? Safety and roadside activity. What's happening on the side of the roads? Is it agricultural? Is there some kind of business that could be affected by dust along the roads? Are there any safety issues on the paved road that might be worse if it's in an unpaved road condition? What can we do about those? Can we add additional signs? Can we do slight modifications to the geometrics, etc.? Anything like that along the roads? Can we put in some barriers, etc.? Any other pertinent issues? We can't list them all because there are so many things out there. But again, the local engineer is going to know what those issues are. And again, walking those roads will help to identify those as long as you keep an open mind as you go along. And then, as I mentioned before, as you walk the road, you want to be identifying representative sampling areas. So the guide provides details on all of these, a lot of photographs in the guide that actually show you examples of particular situations of all of those issues that we have listed up above there. In terms of the testing and the sampling locations, so identifying locations for the dynamic cone penetrometer tests, where to do the layer thickness checks. Those will usually be in the same areas as you're doing material sampling, because when you dig the hole to take the materials out of the road, you can check the layer thicknesses at the same time in that hole. The frequency is going to depend on the project length and the variability. Again, there is guidance provided on how frequently to choose these and how to identify where you have the variability using the dynamic cone penetrometer and the visual assessment. And I say a lot of information on the DCP provided. It's a very, very useful tool, and we certainly support its use. So great for checking layer thicknesses, very good for checking what your subgrade strengths are and how much thickness of material you're going to need on top of that. That's covered in the design phase. We'll touch on that a little later. Identifying moisture-related problems. So when you pull the DCP out of the ground, if it's got a thin layer of wet slime on the surface, you'll be able to identify that. Certainly for identifying uniform sections, and then identifying material sampling locations. And then as I said, we use the material samples to check the material properties and to predict the likely performance. So the laboratory testing, very important phase, not expensive, and certainly worthwhile doing it. You want to be sampling existing materials from each layer, including the subgrade and any supplemental materials if you think you're going to need to bring these in. So this could be materials to increase the thickness, might be just normal aggregate base type materials that you're going to put on the top of the road, or if you've got a very coarse gradation and you expect the road to have severe raveling and severe washboarding after you've done the conversion, like that photograph in the top right-hand corner, then you might just want to be bringing in some fine material, maybe a little bit of bentonite, something along those lines, to get a good or better material suitable for an unpaved road wearing course. If you're going to incorporate the old existing asphalt concrete or chip seal surfacing into the layer, it's a good approach to follow, but often very difficult to determine what the grading of that material is going to be after it has been processed. So in the guide, we have included an example gradation of asphalt concrete if it is processed with a recycler or a milling machine that runs down the road. So you can use that to factor that that material into your gradation. The test that we're looking for is a standard grading analysis. We need the information from the different particle sizes. We require some kind of a plasticity test. We prefer the bar linear shrinkage test. It's not very commonly done in the United States, but it's a very, very simple test and can be done as part of your Atterberg limits. We've included a test method for the bar linear shrinkage in the guide. It's very similar to the plasticity index, but it's less subjective than when you're determining the plastic limit. So we tend to get a more accurate result, and we get a very good correlation between the bar linear shrinkage and the and performance on the road. And I'll explain that in the next couple of slides. If you can't do a bar linear shrinkage, then you can use the plasticity index, and the bar linear shrinkage is, as a rule of thumb, usually about half of the plasticity index. The California bearing ratio test is also recommended if you think passability is going to be a concern. So if you're in a high rainfall area and you do have slippery or impassable conditions, you might want to just do a California bearing ratio to make sure that you have sufficient shear strength to ensure that you don't have rutting or any kind of vehicles getting stuck in the mud situations. Once you've done those tests, you want to check those results against your specifications. And we also suggest checking it against a performance prediction chart to get a basic idea of how those materials are likely to perform. So we do provide information on this little chart. It looks a little busy because there's a lot of text in it. But basically, it's just a simple plot of the clay properties versus the particle size properties. So on the x-axis down at the bottom, we have a parameter called the grading coefficient, which is essentially just the ratio between the coarse, intermediate, and fine particles in your materials. We obviously want a good ratio between the three of those to make sure that we get good aggregate interlock. It's calculated from 3 sieve sizes, and it's just a very, very simple arithmetic calculation. On the y-axis, we have the clay factor, which is essentially your bar linear shrinkage multiplied by the percentage passing your number 40 sieve, which is the material that the bar linear shrinkage or the plasticity index is done on. So again, just a very simple calculation. And then if you plot your material properties on this chart, it'll give you an indication of how that material is likely to perform and what you need to do to those materials to get them to perform well. So again, materials that have no clay or very little clay in them as a binder, potentially insufficient fines in the material, then that material is going to be likely to washboard and ravel. If we have material on the right-hand side that is essentially gap graded, it has more coarse than fine material in it, then that's likely to ravel. Up on the top here, we have the slippery and the dusty materials. We want to be adding a little bit of coarse material to factor those in. And then right on the far side of here, we have the erodible. So basically a very simple chart off of some very basic laboratory tests that will give you an indication of how that road is likely to perform. Again, here we have the erosion and the raveling materials on that. So those are indicators of what your material is likely to perform. So plenty of information on how to do this in the guide provided, and what it all means to you in terms of the unpaving process. And you can plot all of the materials from your individual layers here, get an idea of what you don't want to touch, what you want to add. If your material on your surface is basically coarse and likely to wash, build, and ravel, then we can, but your underlying subgrade materials are in this area over here, then we can add a little bit of this to a lot of that and be able to move that material into that good factor. So a lot of information provided in the guide on how to do that. In terms of the DCP analysis, you might have some software that came with your DCP to analyze that. We're happy that you use that. There are some online tools that will also help you to do that. But just a simple plot in a spreadsheet and then to plot it as a graph is also a very useful tool. And you can see here where we have this basically a change in the rate of the penetration of the DCP, then that basically gives us an idea of where the material is changing. And again, this is an example of an actual project that I did. So we did 4 DCP tests along the length of the road, and you can see how useful the DCP is for picking out the variability. So often we had some pretty rapid penetration in this area over here on the left-hand side, and more consistent penetrations on the right-hand side. So again, on the left-hand side is probably going to need a little bit more work compared to the rest of the road. We have included a table like this in the guide that basically just converts the penetration rate to an approximate California bearing ratio. Again, you're going to want to be using this to identify what kind of thickness you need to ensure all weather possibility depending on your traffic. So again, if you've got very poor materials, that implies you're going to have to bring in some additional material to beef up the road. If you've got very good or good materials, depending on what kind of traffic you're carrying, then that will more than likely be sufficient, and you'll be able to use the existing materials that you have in place. So that pretty much wraps up the investigation. Again, there's a whole series of checklists for doing everything that we've covered in that investigation side. Checklists or forms, you can basically fill those in and staple those together, and that will essentially form your report. We do understand that most folks don't like writing reports, so if we can just convert our checklists, which has space for recommendations on that and comments, we just convert those checklists to a report, and that's going to guide you into the to the next phase of the project. Issues you want to be noting on those forms, primarily, do you have sufficient material out there to be able to produce a good quality wearing course, unpaved road wearing course, or are you going to need to bring in some additional materials? Are there any subgrade concerns? If you've got some wet problems out there, then that could lead to passability problems later down the line. Do you have drainage issues? Are there any underground services that you need to take care of? Obviously, you don't want to be putting a milling machine or a recycler into a road and start ripping up gas lines and cables. Any significant safety issues that are out there that you're going to need to address. You don't want any safety problems materializing after you've done the conversion. Any other fatal flaws, like if you have steep slopes, are you going to have problems with erosion and passability and slipperiness on those steep slopes? Are there some situations with frost heave that you might have to deal with? If you're having frost heave problems on the paved road, are you going to have those same problems on the unpaved road? And what do you need to do about them? Some other factors, do you have a lot of existing crack sealing in the road? Because if you have a lot of that rubber crack seal, that might be a problem to recycle, and you might have to remove some of that crack seal before you can go ahead with that material. Okay, so that's in a nutshell the investigation phases. It's pretty detailed in the guide, step-by-step process on how to do that. In the time that we have available, I've just tried to shoot through it and get it covered as quickly as possible. So the next phase is the design. The guide focuses on what we call an active conversion. So you're actually going to go out there and physically do something about it, as opposed to just letting it go to a passive conversion on its own, as we see in this top right corner. So we're not covering passive conversion in the guide, only the active conversion. So the design is done to ensure that the converted road is better and safer than the distressed paved road. We must be looking to provide safe all-weather passability at all times. Dust is likely to be a key issue raised by the public, so in a lot of instances we may be wanting to consider a chemical treatment as an integral part of the design and the conversion and the maintenance program. Again, a lot of work has been done to show that by using an appropriate chemical treatment, we can significantly reduce the costs of maintaining that unpaved road, simply because we're not losing fines from the road, which means we don't have to maintain it as frequently as we would if it wasn't treated, and we don't have to replace the gravel as frequently as we would if it was not treated. So the cost analyses are out there to show that treating the road is going to often be more cost effective than not treating the road. Just some of the design considerations that are covered in the design. Again, it's kind of a step-by-step logical process. So the first thing we want to be looking at is the thickness design, and then the material design to make sure that whatever we produce out of mixing our existing materials and adding supplemental materials is going to give us that good performance that we showed from that prediction chart. Some information on drainage design, chemical treatment selection, safety considerations, and then at the end of all of that is to put together a conversion plan. So what we have in our minds of what we're going to do based on the investigation and the design phase, to make sure that we have a plan so that the contractor or your personnel within the agency who are going to do that work know what they need to do and what is expected at the end of the day. So again, thickness, we rely on the Federal Highway Administration Design and Construction of Unpaved Roads Guide, basically based on traffic. We have our subgrade California bearing ratio, which we can determine from our dynamic cone penetrometer tests, and then that combination of traffic and strength will give us an indication of what our minimum gravel thickness will be. So again, if we have 25 to 50 trucks or more driving on the road, and we have a relatively weak subgrade material underneath that, bear in mind that we're going to need at least about 12 inches of gravel on there to make wearing course gravel to make sure that we have all-weather passability. And you're going to need to determine whether you have that gravel out there or whether you're going to have to bring in some additional gravel. The material design. So this is basically focusing on optimizing the properties of the wearing course layer to reduce the maintenance and regraveling frequencies. We must obviously meet your agency specifications, and we would like to add that you want to be also looking at your performance requirements based on the chart that I discussed a few slides back to make sure that you're actually going to get good performance out of that material. The guide covers 5 likely scenarios for your material design process, okay, and this is going to depend on each of your situations out there when you do the road. So the first scenario that we have is you just mill off that surface, assuming that a lot of it is gone already. You're going to mill off what is remaining there, and you're going to use your underlying layer as is for the new wearing course. So it might have been an unpaved road before. It might meet the requirements that you need for an unpaved road wearing course and your thickness. So it's just simply a case of getting rid of that that old distressed pavement and running on the material underneath. The next scenario we cover in the guide is incorporating some supplemental material on top of the surface. So basically your existing structure is fine. Paved surface is pretty much intact, but really just about to distress out and become a major problem. So what a lot of folks do is they might just bring in another 6 inches or so of aggregate and just dump it straight on top of the paved, shape it, compact it, and that becomes your new wearing course. So it's not really a case of unpaving, but just converting straight from that paved road to an unpaved road without actually taking that old surface or incorporating that old surface in. Scenario 3 is where the surface is removed and the underlying layers are actually recycled to create a new wearing course. So that's basically where you have a material under there. It's probably reasonably good quality aggregate base materials that are going to potentially washboard and ravel, that will need to incorporate some additional materials, maybe some fines from underneath, to bring it up to a good unpaved road wearing material. Scenario 4 is where all the materials are recycled. So you're going to include that asphalt surfacing and the underlying material and potentially some of your subgrade materials to boost your fines content. And then scenario 5 is kind of the same as 4, but you are also bringing in some additional material, maybe to boost your thickness, or maybe just some fines to give you some binding ability to prevent that washboarding and raveling. So all of those 5 scenarios are essentially covered. Now, to determine what your blend of material is, especially on those last 3 scenarios, involves a process that we have developed. So there's a whole manual process that you can do in the guide, and there's an example of the form that you need to do it. It involves some little basic arithmetic and a test to check that you're actually on the right track once you've done the blend. So it's basically an arithmetic process validated with a test of those blended materials to see where it plots on the chart. We have also developed a web-based tool for doing it for you, so it's just a little bit easier. You don't have to do the arithmetic. The web-based tool will do it. The link to that tool is here on the screen. It is also incorporated into the guide. Right now, we've taken it down because we've done some beta testing with it with some folks. We've identified a couple of bugs and improvements. So we are doing those improvements right now, but by the time the guide is released, it will be back up on the system. And that'll help you come up with a good quality blend with your materials, maybe some supplemental materials, and then you can check that it is going to give you that good performance that you're looking for. So these, again, you probably can't see this, but these are basic screenshots of that tool. So basically some introduction, some links to the guide, a disclaimer, and then the tool itself where you just put in your existing material properties, your supplemental material properties, and then you just fiddle with your recycling depth or your mixing depth to make sure that you're going to do it. Then as you make those changes, it will automatically plot on the graph here to show whether you're in that good box or whether you need to do some additional changes to the material. The next step is the drainage design. Again, this is kind of standard for an unpaved road. So we mostly just refer to the Federal Highway Administration and US Forest Service guides because there's a lot of good information in there. Repeated in the guide, obviously, to try and keep the guide as thin as possible. But the primary thing is that if your paved road was 2%, you're generally going to have to change that to around about 4 to 5% to make sure that you get that water off the road and you don't get the situation of ponding in the middle. So you'll typically get that with a 2% crossfall, whereas your 4% crossfall, like the middle photograph here, will help you get that water off the road as quickly as possible to prevent that potholing down the middle and softening of that material. Chemical treatment selection refers to another guide that was produced primarily for that. So again, it's not repeated in the guide. We just refer you to the other guide. There is a link to where you can download it. And again, you can either do that selection process manually, or you can use a web-based tool that is up and active to guide you through that process. So again, these are the screenshots from the tool, the link to the guide. You basically put in your material properties. It will plot that wearing course material on the chart to show you where you're going to work, and then entering traffic and climate details will give you a basic indication of which chemicals are going to work well and which chemicals are not. Again, transparent process. Basically, green means it's good to go. Orange is warning. Red is don't do it. The orange is basically saying you can still do it, but keep in mind that either traffic or the climate or your material properties might influence the performance of that chemical treatment. And again, you can adjust your materials or change your input parameters to see what affects the process. The safety considerations, there's a bunch of information provided in the guide just of things that you can do to make sure that the road will still be safe after you've done the conversion. And we have also included quite a lot of information in the appendices to help you along that way to make sure that it is as safe as possible, that you can meet some basic minimum federal and state requirements to ensure that the road is as safe as possible. Again, a lot of those issues are probably going to need to be addressed by some additional road signs, just to warn people that sharp corners are coming up, that there might be some localized flooding, any situations like that. So basically, those are all the design parameters. The last thing to do in this phase of the study is the conversion plan and the specifications. So it's just basically summarizing your design, preparing a specification or adjusting an existing specification to factor in what you want to achieve. Again, there's an example conversion plan form provided in the guide. In terms of specifications, again, it's based on the conversion plan, so it's just taking what you've designed and turning that into something that a contractor can follow to make sure that he delivers what you want to get. And in terms of the specifications, there is some guidance provided in the Federal Highways Guide and also in the Chemical Treatment Selection Guide. So basically just following or cutting and pasting some of those specifications in addition to what you have in your standard specifications to make sure that you get a good job. So once you have the plan now, then the next chapter in the guide is basically just highlighting some issues that need to be taken consideration to make sure you get a successful conversion. Things that are covered include equipment, the importing and spreading of supplemental materials if you need them, the actual recycling and mixing process to make sure you get a good quality uniform product, compaction and shaping, very, very important to make sure that you get the compaction, that you're not going to lose the materials by traffic displacement, and you're not going to lose your shape due to traffic compaction. How to apply the chemical treatments, again, reference to the chemical treatment selection guide, and then some basic information on maintaining that road once you have done the conversion. Just some key issues that are highlighted there. It's really similar to standard unpaved road construction. So there's a lot of very, very good information in the Federal Highway Administration Guide and also the Chemical Treatment Selection Guide in terms of applying those treatments. Some guidance on looking for opportunities to correct some minor geometric and safety issues where it's feasible, maybe taking a couple of dips out where water tends to pond, potentially trying to smooth out a curve, maybe provide a little bit of super elevation or something like that, that will just make it a little bit safer to take those corners. Just in terms of enforcing the specifications, making sure that the contractor does adhere to those specifications, especially in terms of shape, compaction, and the quality of the blending of your different materials. Some guidance on quality control and quality assurance that you can do. Remember, we do trust the contractors, but you want to make sure that they are doing what they've been told to do and what they are being paid to do. And some guidance also included there on taking the necessary safety precautions to make sure that you don't have any accidents on the road while that conversion is actually in progress. Okay, so that was a quick snapshot of the primary chapters in the document. I think we're running a little late, but we're still in time. And I'm going to ask Laura to take over the screen and cover the life cycle costs and public involvement. Over to you, Laura.
All right, thanks everyone. Let's see. Let me move down to the correct slide. There we go. This is just a reminder that if you are on the line and your computer or phone line is not muted, please do so. I did go ahead and mute some of you, and let's make sure when we get to the end of the webinar for questions and comments that you unmute your line if you have a question. There's also a chat box within WebEx where you can type a question or comment that you have that we can address at the end. So moving forward with life cycle costs, we have a whole chapter on this in the guide. Essentially, this provides an opportunity for you to look at the full life cycle cost of what would be a cost-effective option. What's kind of been found in the past is that for higher volume roads, and unpaving the road may not be the most cost-effective option. But if we're looking to lower volume roads, it may be a more cost-effective option. And so that's something that should be considered. But again, it's really important that you don't just consider that initial cost of converting the road, that you look out 5, 10, maybe 20 years at the full lifespan to determine what the maintenance costs are going to be and fold that into the cost of the project. It may make you make a choice that you weren't thinking originally was affordable or on the table. From this project and the NCHRP project that we've done in the past, we were able to collect some limited cost data on converting roads from paved to unpaved. Specific to Minnesota, we found the average cost to unpave is about $6,600 per mile. This is a rough number. Keep in mind, at this point in time, it's been really hard to get accurate cost data, and we're basing this number on some folks that were willing to provide the information. So what we're asking of you is, as you go through and you do these conversions, you look at all the cost information and you collect it all, and if you're willing to, maybe even share that information. And by cost data, we mean everything from the person hour and the equipment hour, additional materials, and I'll go into that in a minute. But a lot of times, people's time and equipment aren't necessarily considered in the cost because they're already covered or paid for. But they're very important when you're looking, especially at the picture on the upper right, where you have extensive patching and maintenance that's gone into this road. And we want to make sure all of that's being accounted for in these life cycle costs. So there are some tools available out there for you. They're free web-based tools as well as guides that are out there, and we highlight all of these in the guide. I'm just going to highlight one in this webinar today, and that's the Local Road Surface Selection Tool. This is a great tool that was put together by North Dakota State University and the LTAP, and they currently maintain it. They've been very responsive with any questions we've had, so as you're going through this, if you have any questions or find any hiccups in the program, just go ahead and email them. When you do sit down to go through this, I recommend sitting down, going through it once, just to see what information you might need. But there is a list of information that is needed to go into this. It's a pretty extensive program, and it's great because it runs all the numbers for you and gives you some really good output. But you want to sit down knowing what your road length is, your width, your ADT, the analysis period that you're looking at. So is that 5 years, 10 years? Are you looking at 20 years? There is a discount rate, and that would be for materials that you can reuse or provide to a different project. So that would be maybe you're milling off some old distressed asphalt that you could use on another project or sell. There are some user cost numbers, number of activities that occur per year, and so that would be, say, blade maintenance, things like that, and the unit cost for each of these items. So that would be person hours, equipment hours, addition of new gravel. But the great thing is when you get to the end of this, it gives you a great summary report of all the information you put into it. So it gives you an estimate of the total cost, the maintenance cost, any salvage value you might have for materials, cost to the agencies, and then a cumulative cost for surface treatments and maintenance over time. And you can look at different increments. So you can set all this information in, and you can print a report for what it looks like at 5 years, 10 years, 20 years out. So again, it's a tool that's out there, and we highly recommend you look into it. There are other tools mentioned in the guidebook. So once that is available on the web, we suggest you look into all of those. Moving forward, Dave mentioned it's very important that you think about communicating unpaving, and hopefully you think about that as you first start thinking about the process. In the past work we've done on this, what we've found is that some unpaving projects were stopped only because of inadequate communication with the public. So just some very kind of basic things that we want you to think about going into this are openness and clarity. A lot of people don't want to lose a paved road, but you need to explain to them why this is even being considered, because a lot of times they don't have an appreciation for the amount of maintenance that's going into it or the amount of funds that are going into maintaining that poorly paved road. We suggest holding a forum for landowners and road users to let them be a part of the process and let them feel heard. A lot of times this can lead to creative solutions and even potential funding options. Some people on a road may say, well, we want to maintain it as a paved road, and we're willing to maybe pay in X amount to do that. So it's another potential solution. By folding these folks into the process, it gives them buy-in in the outcome. And that's very important for moving this forward and gaining more public support for the process. One other thing that we highly recommend is creating a point person within your agency that can answer questions and receive feedback from the public. This will allow you to have one unified response when people do call, and it'll also allow people to, when they call, end up talking to the correct person to get the answers they're looking for. So here's a little flow chart that we have in the guide, and it's a pretty simple one, but it looks at, has your road been identified as a candidate for unpaving? If your answer is yes, here's some suggested communication that you consider using. Maybe you write a letter to impacted landowners or users that need to use the road to access their land or their business. Ideally, this would be sent out, again, before any unpaving is going on. Maybe you consider holding a public or town hall meeting where you invite people to attend, and you can present the concept of unpaving and talk about what roads have been identified as potential candidates for unpaving. Or maybe you choose to speak to the media and do a press release, maybe informing people in that neighborhood of what's going to be happening or of this public or town hall meeting. The next step is, okay, not only are these roads identified as candidates for unpaving, but you're going to go ahead and move forward with an unpaving project. If your answer is yes, you are going to move forward, we then say you should probably follow up and send a letter to specific landowners or people that need to use the road and let them know what your schedule is for road work, what they can expect in that road work project, and what they can expect at the end. And if they do have any questions, here's who you talk to. And maybe even informing the media and letting them know road work will be done on this road at this time. Some tools that we provide in the guide are suggested communication using either your agency's website or social media. We provide an example formal letter that you can fill in and tailor to your project that can be sent out to people. We also provide a template for a PowerPoint that can be used for town hall meetings or public meetings. And it goes into pictures of what maybe a poor performing road might be or a good performing gravel road, explaining the unpaving process. It allows you to insert slides on maybe your cost analysis and the roads that you've identified as potential candidates. So it's just a tool for you to use to start this communication. We've developed a 2-page fact sheet. Here's the front page of the fact sheet that you can print. It's a 2-sided sheet, so you can essentially hand those out as information sheets or email them out. And we also have example press releases that can be used for the media in the guide. So with that, that's a high-level overview of information that will be presented in the guide. And again, the guide is in its final revisions at this point in time, and the goal is to post it to the Minnesota DOT Local Road Research Board website, along with this webinar and all of the tools that we've mentioned in early to mid-November. So at this point in time, I would like to open up the floor to folks on the line and take any questions that people may have. All right, if you've muted your line, you will need to unmute if you would like to make a comment or ask a question. Or you may go and, go for it.
I have a question. You referenced a rough estimate of $6,600 per mile for unpaving. What costs were included in that estimate? How did you come to that figure?
That's a great question. So we sent out a survey to all the counties in Minnesota asking for cost information. So we were at the whim of what they had and were willing to provide. Some folks had every single line item covered in that, and then other folks only had cost of time and materials. So that's part of why we're asking you to try and track your costs as closely as you possibly can. There's a much better description and summary table of information to track your costs in the guide. But ultimately you'd want not only materials and time, equipment, person hours, but also those long-term maintenance, reblading, dust control costs folded in as well. Any other questions, comments? And if you need your line to be unmuted because I've muted it, you may send me a note on the chat and I can unmute for you. All right, Dave Jones, any questions, comments?
Nothing from my side, no.
All right, well, thank you very much. Please know that you're always welcome to reach out to Dave Jones or myself with any questions or comments. We had one come in on the chat and it says, is there any application for unpaving city streets? Dave, do you have any comments on that? Otherwise, I'll handle that.
Well, I guess it's the same criteria that you would use that are covered in the guide. It's not only applicable to rural, it's applicable to any roads. I know there have been some situations in Wyoming, in some of the the small towns in Wyoming, where those towns have converted back to unpaved just to provide a reasonable level of service. Again, it would just be a case of going through the steps, working with the public, and checking that you could do it and still produce a road that was better than the paved road. I would imagine, though, that you would have to do quite a bit more public involvement for those people that are living along the road to make sure that that some of their concerns were addressed.
Thank you, Dave. The only thing I'll add to that is I know it's been documented in Vermont. There was a city street that was converted, and there's media reports, and we've highlighted that in the NCHRP synthesis document as well, if you want to find out more information about that.
Yeah, I believe there was one in North Dakota as well. I did see a presentation on that as well. So I wouldn't call it a city street like something in downtown Minneapolis, but it certainly was a rural community, but certainly a town street that had a lot of residences along it, as opposed to just a road that ran through farm fields.
Great. Any other questions or comments? All right. Well, thank you everyone for participating. I will work with Minnesota Local Research Board to get this posted to the web. And again, feel free to reach out with any questions or comments. I'm going to stop recording.